In Part 1, you just learned about the method of heat transfer that occurs when molecules are in direct contact with one another, conduction. In Part 2, you'll learn about a unique and efficient method of heat transfer that occurs only in fluids, convection. Read and highlight the introductory paragraph of Part 2. Notice that density plays an important role in the process of convection and that fluids are defined as both liquids and gases. Turn to the observations section on slide 2. This is where you will insert a diagram and narrative of your observations during the 2 demonstrations I am about to do. As described in the procedure step 5, I've placed a cold blue-tinted bottle of water on top of a hot red-tinted bottle of water. Watch what happens as I pull the card separating the 2 and allow them to mix. Draw a diagram on a piece of notebook paper and insert an image, or use the scribble tool to sketch an image directly onto the lab slide. Describe your observation in words as well. Now we'll move on to the demonstration described in step 6. This time I have a bottle of hot red tinted water on top of a bottle of cold blue tinted water. Watch what happens as I remove the laminated card. Complete this portion of the observation chart in the same way you did for the previous slide. Pause the video while you complete the questions on slide 3. Do this before going on to part 3. A third way that thermal energy can be transferred is by the absorption of transverse waves, whose energy is then transformed by the absorbing substance into increased kinetic energy of its molecules. In the optics lab, you learned that colored objects reflect certain wavelengths and absorb others. Now you'll see if color affects the amount of thermal energy transferred to a substance. Read and highlight the introductory paragraph on slide 4. Read through the directions on slides 4 and 5, paying particular attention to steps 9 through 12, which give you information you need to set up your data table. On slide 6, fill in the labels for the remaining columns and rows. Pause the video while you do this. Your table should look like this. Here is the setup as described in the directions. I have a light arranged so that it is equally distant from the black box and the white box. I have a temperature probe set up so that the tip of that probe is held inside each box but not touching the side of the box. Those are connected to a LabQuest. And before I turn the light on, we'll record time 0 minutes as what I'm telling you now as I read off the LabQuest. So the black box's initial temperature is 32.3 degrees C, and the white box's initial temperature is 32.2 degrees C. Those readings are recorded here in the data table at time 0 minutes. I now turn the light on and the LabQuest so that the timer starts, and we'll record the next temperature at 5 minutes. It's now 5 minutes and the reading from the black box is 56.5 degrees C and from the white box is 45.6 degrees C. Those numbers are recorded in the row labeled 5 minutes. Now 10 minutes and the black box temperature was 67.1 degrees C and the white 50.1 degrees C. And you should be aware that this flips back to time 0, which is why those aren't the numbers that you see right there. Record those numbers and then calculate delta T for each box and add those values. Take a closer look at the graph. Remember, the red line represents the temperature in the black box and the blue line represents that in the white box. You can take a screenshot of the LabQuest graph and paste it into the section of slide 6 where it asks for the graph, or you can sketch it using Scribble. Finish the questions on slides 7, 8, and 9 to complete the lab.